In this video, I will explain the concept of the coloring of a graph in graph theory. So let's start with a couple quick definitions. We say that the coloring of a graph is the assignment of colors to the vertices such that all adjacent vertices have different colors. The chromatic number of a graph, denoted as chi of g, so this is the Greek letter chi, is the least number of colors needed to make a coloring. Now, to actually find the coloring of a graph, we use a two-step process. The first is color the vertex with the highest degree, then use the same color to color all possible non-adjacent vertices. And step two is we just repeat step one until all of the vertices are colored. So I have three examples of graphs down here. Let's go ahead and find the coloring of each graph and the chromatic number of each graph. So let's consider this first graph right here. The first thing that we need to do is find the degree of each vertex in this graph. Now remember, the degree is just the number of edges that are connected to each vertex. So here are the degrees for each of these vertices in this graph. So we can see that two of the vertices have a degree of 3. In other words, there are 3 edges that are connected to each vertex. So we can pick either one of these vertices to start with. So let's just say that we pick this vertex right here. Now we can pick any color that we want to color this vertex. So I'll just choose red for this example. So let's color this vertex red. And now what we're going to do is color all of the vertices in the graph that are not adjacent to this vertex. So we can see the only other vertex that is not adjacent to it is this one right here. So we'll color this one red as well. Then we'll move on to the next highest degree vertex. So we can see that all of the remaining vertices have a degree of 2. So we can pick any one of them that we want. So let's just pick this one up here and let's color it green. Now we need to color every vertex that is not adjacent to this vertex. In other words, that doesn't share an edge with this vertex. We need to color it green as well. So we could color this vertex green, and we could also color this vertex green. So now that we have colored all of the vertices in this graph, it means that we're done with the coloring. And what we'll notice is that no two adjacent vertices have the same color. So that's the definition of the coloring of a graph. And we'll also notice that it only took 2 colors to actually achieve this coloring. So that turns out to be the least number of colors needed to make this coloring. So that represents the chromatic number of the graph. So for this graph, we're going to write the chromatic number, or the chi of g, is 2. Now I should also note that when we say that a graph has a chromatic number of 2, sometimes we also call this 2 colorable. So if you happen to see that term thrown around, 2 colorable, it means that a graph can be colored using only 2 colors for all of the vertices in the graph, such that no adjacent vertices have the same color. All right, now let's check out example number 2 right here. To find the coloring for this graph, let's first find the degree of each vertex in the graph. So for this graph, it turns out that each vertex has a degree of 2. In other words, there are 2 edges connected to each vertex in the graph. So it doesn't actually matter which vertex we start with for our coloring. So let's go ahead and just choose this vertex right here as the first one to color, and we'll use red again as our first color. Now let's color all non-adjacent vertices to this vertex red. So we'll color this vertex red, and although this vertex is not adjacent to this starting vertex, we'll note that no 2 adjacent vertices are allowed to be the same color. So we're not going to color this one red since this one already is red. So we'll skip that one, and then we'll color this vertex red right here. Okay, now we can move on to the next highest degree vertex. So again, all the vertices in this graph have a degree of 2, so we can just pick any vertex we want. So let's go ahead and pick this vertex and we'll color it green. Then we'll try to color all of the non-adjacent vertices green as well. So this one can be green, this vertex can also be green. So for this graph, we'll also find that we were able to color the entire graph using only 2 colors. So the chi of g, or the chromatic number of this graph, is also 2. And one fun fact about this graph is that it's a cycle graph. So the vertices are connected in such a way that they form a cycle or a closed loop. Now it turns out all cycle graphs with an even number of vertices are 2 colorable. In other words, they all have a chromatic number of 2. And that's because a cycle graph, which has a closed loop like this, you can just color each vertex in alternating colors. So for example, if you had, let's say, 4 cycle graph like this, it's pretty easy to see that every other vertex could just be colored using alternating colors. So just keep that in mind for cycle graphs with an even number of vertices. They are always 2 colorable. All right, now let's check out our very last example, graph number 3 right here. To find the coloring of this graph, let's first find the degree of each vertex. So for this graph, we can see that there are 2 vertices with a degree of 4. So we can pick either one to start with for our coloring. So let's go ahead and pick this one right here. So let's color this vertex green. Now, every non-adjacent vertex needs to be a different color. But what we'll notice for this graph is that this vertex, it's actually directly connected to all of the other vertices in the graph. In other words, there are no non-adjacent vertices for us to color green as well. So that means we're done with this vertex. Now we'll move on to the next highest degree, which would be this vertex right here. So let's color this one red. And now what we'll notice for this one is it's also directly connected to every other vertex in the graph. So there are no other vertices that we can color red. So now we'll move on to the next highest degree. So we have this vertex with a degree of 3 and this vertex with a degree of 3. So let's choose this one to start with. Let's go ahead and color this vertex blue. Now we need to try to color all non-adjacent vertices blue. So we'll notice that this vertex all the way over here is non-adjacent. So we can color that one blue as well. But we can't color this one blue because it's adjacent. So now for this very last vertex right here, we'll have to choose a different color. So let's choose purple. So what we just found for this graph is that we needed 4 colors in order to color the vertices of the graph in such a way that none of the adjacent vertices have different colors. So the chromatic number of this graph, or chi of g, is 4. So those were just 3 quick examples of how to find the coloring of a graph.